Okay, today I figured I'll print a camera mount for my iPhone so that you don't get all the jiggly video stuff. Found a model on Thingiverse. Warming up the printer. We take our model into our slicer. Add it in. That's the mount. Open. Standard settings, export G-code to the SD card on the printer. Okay, now we go back to our printer command. Bed's heating up. I'll get the hot end heating up as well. Monitoring the temperature here so we can see how quickly it gets to temp. Figuring to use a Gorilla Pad, a Gorilla Grip camera mount or a tripod, anything to stop the shakies. I will most likely speed this section up so that you don't have to wait for the minute or so it takes to heat up. While we wait, this is my printer. It's an Aluminatus Trinity 1. Printer is built and designed by a guy called Ezra Zygmuntowicz, who unfortunately passed away a couple of years ago. I've done a rebuild on this machine, replacing the brains inside with a smoothie board. Special on this printer, these are triple stack NEMA 17s with 10 start 25mm pitch feed screws. Most of the 3D printers you'll see around the world only have belts, not lead screws, especially on the X and Y. Now, on my YouTube channel there's a video I took when I rebuilt these stages of it running at 700mm a second, which is blazing fast. I'm printing at 0.4mm layer height, which is about as coarse a layer as I can produce on this printer. It's typically related to the size of the orifice in the head. I've got a 0.5mm nozzle, so you typically want a little bit of over round such that your thickness is less than your opening size, so that you get a bit of squish as you're laying down filament on the printer. So 0.4 is about the maximum layer height I can use on this printer. Cooling fan, geared drive, direct drive extruder. This is a 5.1 to 1 ratio planetary gear, metal gear, all metal drive components. On the earlier homegrown rep wraps you'll find things like a Wade's or a Greg's extruder, which uses plastic gears. You can build it, you can print it, makes it nice and cheap, but they're the parts that wear out first. So as you're printing, you do get a degradation over time. With these you don't. This is an all metal gear set, and the extruder is no longer a part of the problem. This is a custom extruder mount that I've designed. Specifically, you'll note this nose that runs between the two gears. This brings the outlet side of that gear to being very closely supported either side of the filament feed. There's a lot of flexible or soft filaments these days, and I built this as a request by a good mate of mine, Daniel Farm. That's a design that I built and prototyped up for him. Specifically on this, I've done a lot of work to ensure that the weight is carried along the drive axis. If you can imagine that this printer is a pendulum, albeit a very lightweight one, if you have your center of mass offset from your center of drive, every time you move backwards and forwards, your tip of your print head is going to be doing this, just by virtue of the inertia in the drive to the mass of the print head. So I've specifically positioned this such that the center of mass matches the center of drive. This is really, really fine tuning for something like this. It's not a lot of people who probably would have thought of that. But, you know, this is my design. The pressure bearing is just a skate bearing, a couple of springs, all that's as per normal. But this is a fairly custom special component. Also in the Aluminatus we have these 12mm smooth rods with IGES bearings, lead screws. Also on the the Y-axis. Not sure if you can really see that in there. Anyway, the print bed is a filler print bed positioned on a sheet of very thin glass with an aluminium spreader, and then below that you can just see a sheet of insulating foam. The reason for the foam insulation is to stop heat loss out of the base. Typically, as you're heating an element, heat will travel out both sides unless you've got some insulation on the bottom, and that just helps us to get to speed faster. Okay, I've talked for long enough now, and we are at temperature. So our next step is typically I just run a couple of extrude until I get some clear snot coming out of the end of the extruder. Okay, then I go to print. SD card printing, there's a memory card on the actual device, so the smoothie has enough access speed to the USB to actually keep up with the moves of the printer. Pretty important on a 3D print is that the first layer is printed slowly. Second part is that the bed temperature, here I'm running a bed temperature of 78. Now 78 is a relative number rather than an absolute number. I haven't bothered to specifically make sure this is exact degrees C 78, but what I have done in testing and setup is I've made sure that this is the temperature that allows the PLA to be slightly off glassy as it's being extruded. This allows the surface of the print to conform very closely to the surface of the filler print. Once the first layer is finished, we then drop the temperature of the bed down below that glass temperature, which essentially allows that bottom layer to solidify, and that helps us to stop lift-off as we print. Secondly, as we're printing, the speed being slow allows the plastic to actually form out of the nozzle to the bed and not be pulled out when the printer gets around a corner. The Z layer height is very tightly adjusted to be exactly 0.4mm, and the extruder is set to ensure that the right volume is coming out at that point. If you go faster, you can end up pulling around corners, which results in a poor adhesion because there is quite a finesse between those layers. Once the first layer is down and the temperature drops, the subsequent layers of plastic on plastic are able to travel quite a bit faster, and that's because the base layer is now rigidly attached to the base of the machine, and printing continues. The filler print material I'm using here is quite a special product. There's a number of people out there who are trying to find really good print products. Daniel at Filler Farm has managed to find a really good print base in this one, and it just works. When it's hot, it adheres very well, and as soon as it gets down to room temperature, the prints just fall off. So you don't end up with any sort of surface residue, you don't end up with lifted off parts while you're printing, and also you end up with a really nice finish on the base and well adhered parts. Things like bed leveling and homing, on this machine I don't have a Z homing. I do have an X homing switch and a Y homing switch down the back, but for Z homing, at the end of my print I return the printer back to Z equals 0 and essentially don't allow the machine to move between runs. There is enough holding force in the mechanics such that the printer stays where it's finished. I power off at Z equals 0, and when I come back on, everything's initialized to Z equals 0. I find that gives me most reliable settings. I'm not relying on Z height switches stays where I've tuned it to, and we get a really good print result. The benefit of the 5.18 to 1 gearing in the print head is such that you have a really small motion at the end. It's very hard to see here, sorry. Very small motion at the extruder, but that the stepper has plenty of resolution to maintain torque and control of such small amounts of motion. But also then when you start to extrude faster, you have enough speed in the extruder to keep up with the requirements of the filament coming through. Because I'm printing at 0.4 layer heights, this is essentially the most extrusion that comes out of this head. As you go to thinner layers, you need motion in your machine to be faster, but you want your filament to come out slower because you're actually depositing less material per layer. And so that's where the benefit of the that's where the benefit of the worm fixed drive, the geared extruder, and also the very tightly controlled repeatability of those axes come into play. You can lay down the 0.1mm layer heights or even 0.05 if you chose. But because of the repeatability of this printer, here's an example print here. This is at 0.4 layer heights, and it is just so accurately. Come on, let's see if we can focus. No. You get beautiful repeatability. There's no ringing, there's no, you don't get that with belts. Here's another piece. This is just support material. So there is jumps and hexes and angles and stuff, but the actual finish layer to layer is just glassy smooth, even at 0.4mm. Nearly finished our first layer. Again, this is why we go very slowly on the first layer, is to make sure we get a really good lay down support base. And having a decent camera mount will help us to actually film without the jiggery-biggery. When I rewired this machine, I'd rewired it all with cable chain access, and I was in the middle of building some new mountings and cable chains designed to actually carry this final piece across, and I needed to adjust the design and ran out of time, as always is the case, but I've got the machine printing as it is at the moment. And depending on how I go, I'll either edit this up, fast forward it, or just post it from my phone because I don't have editing software on the phone. Any moment now. And this is the speed it gets up to once it's actually printing. I still have the speed settings quite conservative because of the layer thicknesses I'm using, and the limit essentially is how fast the plastic will come through the extrude nozzle rather than the speed of the motion components of this machine. I think it's maxing out here at about 150mm a second, which isn't that fast really, but for the finish I'm getting and the layer heights I'm using, it's actually really quite amazing. favourite fill to use on 3D printed parts is a honeycomb fill at about 0.2, or that's 20% infill percentage. You have full control over the percentage of infill you have in solids and the surface finishes and so forth. I tend to like the honeycomb because it's quite strong in both the X and the Y direction, whereas a linear fill actually has voids in Z in the subsequent layers. And this ties it together in 3 different directions, the 60 degrees, or sorry, 120 degrees. The linear orientation of the layers ties it in really quite nicely. And if it works for bees, why can't it work for us? And the print continues.